Something strange is moving through our solar system right now, and almost nobody is talking about it. If you want to stay ahead of what's unfolding in space, subscribe now, because what we're about to walk through does not end where most people think it does. For months, astronomers believed they were watching just another interstellar visitor. A rare one, yes, but still familiar. A single object drifting in from the dark between stars, glowing faintly green as it passed the sun. 3. Interstellar Atlas, the third confirmed object ever detected from outside our solar system, following the path set by Oumuamua and Borisov before it. At first glance, it looked like history repeating itself, but history does not usually change in a single night. At exactly 2 a.m. UTC on September 19th, an amateur astronomer in northern Chile was scanning the sky with equipment far less powerful than the machines operated by NASA or the European Southern Observatory. He wasn't searching for anything unusual. He was simply following Atlas, tracking its faint tail as it slid across a familiar patch of stars. Then something appeared that wasn't supposed to be there. 9 tiny points of light arranged around Atlas, moving with it. Not drifting behind, not scattered ahead, locked in perfect formation, like sparks orbiting a flame. At first, the image looked wrong, too symmetrical, too clean. It resembled a software artifact, the kind of glitch that appears when cosmic rays strike a camera sensor at just the wrong moment. But the lights didn't vanish. Within hours, observatories across the world pointed their instruments toward the same coordinates. The James Webb Space Telescope adjusted its schedule. The Hubble Space Telescope re-examined archived frames. The Very Large Telescope in Chile confirmed what no one wanted to say out loud. 3. Interstellar Atlas was not alone. What made this discovery unsettling wasn't just the number of objects, it was their behavior. All 9 moved at the exact same velocity as Atlas. No lag, no drift, no chaos. In natural astronomy, fragmentation produces mess. Debris spreads, trajectories diverge. But this was different. The 9 objects held formation with machine-like precision, as if bound by an invisible framework. Spectral analysis made things worse. Using Webb's infrared spectrograph, scientists examined the light reflecting off each object. If they were fragments, their composition should vary slightly, like broken shards from the same stone. Instead, every single one showed the same metallic fingerprint as Atlas itself: nickel, cobalt, and traces of alloys that don't typically appear in comets or asteroids formed by natural processes. Even more disturbing was their energy output. 3. Atlas had already confused scientists with its thermal signature. Estimates suggested it was emitting energy on the order of 10 gigawatts. That alone pushed the limits of natural explanation. But the 9 companions radiated nearly double that, 20 gigawatts each, contained within objects no larger than city blocks. To put that into perspective, a single one of these objects was producing enough power to light an entire large nation. Nature does not do that. Comets glow because ice turns into gas. Asteroids reflect sunlight. Neither process produces sustained, concentrated energy at this scale. Engineers at NASA's Jet Propulsion Laboratory ran simulations trying to reproduce these readings using known physics. Every model failed. The equations broke down. Fusion couldn't explain it. Chemical reactions were nowhere near sufficient. Even speculative ideas involving exotic matter couldn't stabilize the numbers. Something about these objects was actively generating and containing energy. The timing of their appearance raised even more questions. For weeks before September 19th, Atlas had been under constant observation. Ground-based telescopes, space-based platforms, NASA's Juno spacecraft, the Parker Solar Probe. Even instruments tracking Mercury's environment had been logging data. Not one of them recorded these 9 objects approaching. According to researchers at the Harvard-Smithsonian Center for Astrophysics, the companions did not drift into view. They appeared all at once, in less than a millisecond. A human blink lasts 300 milliseconds. A camera flash lasts about 5. These objects emerged tens of thousands of times faster than either. There was no gradual reveal, no approach vector. One frame showed Atlas alone. The next frame showed a convoy. To astronomers, It felt as if the sky itself had changed state. Immediately, theories flooded in. Some suggested Atlas had released the objects, deploying them like drones once it reached a certain distance from the sun. Others proposed they had been dormant, cloaked, or hidden until solar radiation triggered their visibility. A smaller group argued something even stranger, that the companions were never invisible at all, only undetectable until they chose to reveal themselves. What united all theories was one conclusion. This was not random. As images leaked online, the public reaction followed a familiar pattern: confusion, excitement, fear, and then the obvious question surfaced everywhere. Why didn't we hear about this first from NASA? Why did it take an amateur astronomer to spot what the most advanced observatories on Earth seemed to miss? NASA and the European Space Agency responded with careful language. Statements acknowledged ongoing analysis, no immediate threat, more data needed. Requests for raw James Webb spectra were denied. High-resolution frames were withheld. Behind the scenes, leaked documents told a very different story. Emergency meetings, closed-door briefings, quiet discussions involving the Pentagon, ESA leadership, and multiple space agencies in Asia. Contingency plans resurfaced. Old planetary defense proposals were dusted off. Private aerospace companies were contacted discreetly about rapid launch capabilities. And yet, publicly, there was silence. Silence has a sound of its own. Because if 9 independent objects truly appeared beside an interstellar visitor, each radiating more power than entire nations, then the truth was already too large to manage openly. Governments understood that. Scientists understood that. And once that realization settles in, a new question begins to take shape, one far more uncomfortable than the first. If these objects are not natural, then they were built, and if they were built, then someone or something put them here on purpose. We haven't even reached the most disturbing part yet. What unsettled astronomers even more than the power output was how the 9 objects behaved once they were visible. They did not wobble, they did not drift, they did not fan out or collapse inward. They held position relative to Atlas with a precision that orbital mechanics struggle to explain without active control. Space is not still. Solar radiation pressure, gravitational tides from nearby planets, even microscopic outgassing forces cause objects to wander over time. Yet these 9 points moved as if locked into a rigid framework, maintaining their distances with almost surgical accuracy. Teams at the European Southern Observatory began running backward simulations, rewinding the clock to see where these companions should have been days or weeks earlier if they followed natural trajectories. The results were deeply troubling. The simulations showed empty space, no gradual approach, no faint signals hiding below detection thresholds, just nothing. Then suddenly, everything. To make sense of this, astronomers compared the event to known natural phenomena, fragmentation events, like those seen with Comet Shoemaker-Levy 9, which broke apart before crashing into Jupiter, leave behind chaotic debris fields. Pieces drift apart, orbits diverge, energy disperses unevenly. What happened with Atlas was the opposite. The 9 companions appeared already organized, already synchronized, already behaving as if they were aware of one another. That is when the language quietly began to change. In internal discussions, words like fragments and debris slowly disappeared. They were replaced with terms like units, elements, and in some cases, probes. Not in press releases, not in public interviews, only in technical meetings and private communications where scientists could speak freely without triggering panic or ridicule. One researcher at NASA's Jet Propulsion Laboratory reportedly summarized the problem in a single sentence during a closed briefing. There is no passive explanation left that fits the data. That sentence never made it to the public. Another detail soon emerged, one that pushed the situation from strange into deeply unsettling. When researchers examined the infrared signatures of the companions more closely, they noticed subtle variations in how each object radiated heat. Not random differences, but patterned ones. Each object appeared to modulate its output slightly differently. almost like separate instruments in an orchestra playing variations on the same theme. This suggested internal complexity. A simple rock does not regulate its heat. A chunk of ice does not pulse energy on command. Something inside these objects was controlling how and when energy was released. Engineers tried modeling them as nuclear processes, but even theoretical reactors require mass, shielding, and waste heat dissipation that simply did not match the observed sizes. If these were machines, they were unlike anything humanity has ever built. At the Harvard-Smithsonian Center for Astrophysics, one hypothesis began to circulate quietly among researchers. The idea was uncomfortable, but it fit the data better than anything else. 3. Interstellar Atlas might not be the primary object at all. It could be a carrier, a platform, a mothership. According to this hypothesis, Atlas was never meant to approach planets closely. Its role was long-distance transit, stability, and coordination. The 9 companions, smaller but more energetic, would handle proximity operations, close passes, detailed observation, interaction with magnetic fields, atmospheres, and possibly even surfaces. This would explain why the companions carried more concentrated power than the main body. It would also explain why they appeared suddenly rather than gradually. Deployment, not fragmentation. The implications were hard to ignore. Probes this advanced do not wander into star systems by accident. They are sent. Not everyone agreed, of course. Skeptics pushed back hard, arguing that extraordinary claims require extraordinary evidence. Some proposed that Atlas had collided with an interstellar object made of unusually uniform material, producing 9 fragments that just happened to retain formation. But when physicists tried to make the math work, it failed. Collisions create entropy, disorder, heat spikes. None of those signatures were present. Others suggested electromagnetic binding, a kind of plasma interaction holding the fragments together. But this too collapsed under scrutiny. The distances between the objects were too large, the energy requirements too precise, and most importantly, plasma structures don't appear instantaneously out of nothing. As days passed, the engineered explanation refused to go away. Then something else happened. Radio astronomers monitoring the region noticed faint, repeating anomalies in the background noise surrounding Atlas and its companions. At first, these signals were dismissed as interference. Space is noisy. Pulsars, solar activity, cosmic background radiation. But the anomalies kept appearing at regular intervals, every 43 seconds. Not exactly 40, not exactly 45, 43. The same number appeared again and again in datasets from different instruments, different continents, different frequencies. Engineers at the Deep Space Network flagged the repetition. When they overlaid the signal timing with the orbital positions of the 9 companions, the alignment was almost perfect. Each pulse coincided with subtle positional adjustments within the formation. Very small, barely measurable, but consistent. To some, this looked like communication. To others, it looked like coordination. Either way, it did not look natural. The story reached a new level of unease when magnetometers on Earth began picking up faint disturbances that lined up with the same 43-second rhythm. These were not strong enough to cause harm. Most people would never notice them, but instruments did, especially those designed to monitor Earth's magnetic environment for space weather. The disturbances were global. Stations in Antarctica, South America, Europe, Asia, all recorded tiny fluctuations that matched the timing of the signals near Atlas. Solar activity was ruled out. No flares, no coronal mass ejections, nothing that should have caused synchronized behavior across the planet. It was as if something outside Earth was gently tapping the planet's magnetic field, over and over, like testing the tension of a string. Some researchers dismissed this as coincidence. Others were not so sure. When seismologists checked their own instruments, they found something equally strange. Ultra-low frequency vibrations, far below the threshold of earthquakes, had appeared in datasets around the same time. Not localized, distributed, too subtle to feel, but unmistakable in sensitive equipment. Earth itself seemed to be responding. This is the point where many scientists became visibly uncomfortable. Because while astronomy is used to dealing with distant objects, passive observation, and slow cosmic timescales, this was starting to look interactive. And interaction implies agency. Publicly, space agencies continue to downplay the significance of the findings. No confirmed threat, no evidence of intelligence, just anomalies under investigation. But internally, the language shifted again. Meetings grew more frequent. Access to certain data streams became restricted. Raw James Webb spectra were placed under review status, limiting who could download or share them. Amateur astronomers noticed the change immediately. Images that would normally appear in public archives were delayed or missing. Observation proposals targeting Atlas were suddenly deprioritized. Even routine tracking updates slowed. It wasn't an official blackout, but it was close enough to raise suspicion. When institutions go quiet, people fill the silence themselves. Online forums exploded with speculation. Some went too far, jumping straight to invasion scenarios or hidden treaties. Others tried to stay grounded, focusing on physics, engineering, and precedent. But even the most cautious voices admitted that something unprecedented was unfolding. Then, from the opposite side of the sky, another object entered the conversation. Cataloged as C 2025 R2 and quickly nicknamed SWN, this new interstellar visitor dwarfed Atlas in scale. It was brighter, larger. Its tail stretched across the sky, 5 times wider than the full moon. Even amateur astronomers could see it without specialized equipment, and its timing was impossible to ignore. SWN was set to reach its closest approach to the Sun within days of Atlas. 2 interstellar objects, one escorted by 9 energetic companions, the other massive, luminous, and approaching from a completely different direction. Both entering the inner solar system at nearly the same time, both scheduled to pass through a narrow corridor near the Sun. And most critically, both reaching their most important positions during a window, when solar glare would blind Earth's telescopes. From October 8th to October 18th, the Sun would sit directly between Earth and the region where the 2 objects would come closest. A natural blind spot, a cosmic curtain. To many astronomers, this was where coincidence finally broke. Random interstellar visitors do not synchronize their arrivals. They do not align their trajectories to intersect the same solar corridor within days of each other. And they do not conveniently hide their most critical interactions behind the glare of the Sun. Unless they are not random, theories multiplied rapidly. Some suggested SWN was unrelated, a coincidence amplified by human pattern seeking. Others proposed it was part of the same system, a larger construct arriving to meet Atlas and its companions. A rendezvous, a refueling, a data exchange, a handoff. Historians began combing ancient records, not because they believed in myths, but because SWN's estimated orbital period suggested something extraordinary, roughly 22,000 years. That meant it could have passed through the inner solar system before, long before telescopes, long before recorded history as we know it. If it had appeared then, humans would not have called it an interstellar object. They would have called it a god, a dragon, a sign, stone carvings, oral traditions, strange symbols repeated across continents. Some researchers dismiss these connections as coincidence or cultural storytelling. Others quietly noted that the timing was uncomfortably precise. Meanwhile, behind closed doors, governments were not debating mythology. Leaked documents suggested that multiple space agencies had begun reviewing planetary defense scenarios, not because an impact was expected, but because the unknown demanded preparation. China reportedly accelerated internal studies related to high-velocity interception. European teams revisited abandoned deflection concepts. Private aerospace firms received discrete inquiries about rapid response capabilities. And yet, publicly, nothing changed. No press conferences, no urgent briefings, just carefully worded reassurances and long pauses between updates. Time, however, did not pause. As Atlas and its 9 companions continued their approach, their formation tightened slightly. Not dramatically, just enough to be noticeable. Their energy pulses grew more regular, their signals more coherent. And Earth's instruments continued to record faint, synchronized responses. At this stage, one question began to dominate quiet conversations among scientists. If these objects are not natural, and if they are not hostile, then what are they doing? Because machines do not appear without purpose. And whatever that purpose is, it is still unfolding. Under normal circumstances, the next step would have been clarity, more data, better angles, a clean explanation that lets everyone breathe again. That never came. Instead, the closer Atlas and its 9 companions moved toward the inner solar system, the more the data behaved like it didn't want to be clean. Every answer created 2 new questions. Every pattern revealed a deeper layer beneath it. One of the strangest developments came from trajectory analysis. Teams at NASA's Jet Propulsion Laboratory and the European Space Agency independently noticed that the 9 companions were not just following Atlas, they were subtly adjusting their positions relative to the planets ahead of time. Before Atlas passed certain gravitational zones, the formation shifted slightly, almost as if anticipating forces that had not yet acted on them. This is the kind of thing spacecraft do. When Voyager 1 performed its gravity assists decades ago, engineers carefully adjusted its orientation long before each planetary flyby. The math was unforgiving. Tiny errors could mean missing a planet by millions of kilometers. Watching Atlas's companions do something similar, without visible propulsion, plumes, or exhaust, made seasoned engineers uneasy. These adjustments were not reactions. They were plans. What made this even more unsettling was how little energy seemed to be wasted. No heat spikes. No erratic motion. Just smooth, efficient changes in position, like chess pieces sliding across a board where the next 10 moves are already known. Astrophysicists try to explain this using solar radiation pressure and magnetic field interactions, but the timing never lined up. The adjustments happened too early, as if the objects already knew what forces were coming. Prediction implies computation. Computation implies intelligence. This is where the debate quietly split into 2 camps. One group argued that intelligence was an unnecessary leap, that advanced but natural physics might still explain everything if humanity simply lacked the right framework. The other group countered that every attempt to avoid the intelligence question required inventing new physics anyway, just without admitting what it looked like. One senior researcher put it bluntly in a private discussion: if you're going to invent magic, you might as well call it technology. Another discovery added weight to that statement. When scientists compared the metallic signatures of Atlas and its companions using data from the James Webb Space Telescope and Keck Observatory, they found something deeply odd. The ratios of nickel, cobalt, and trace elements were nearly identical across all 10 objects. Not similar, nearly exact. In nature, even objects formed in the same region show variation. Small differences in pressure, temperature, and time leave fingerprints. But these fingerprints were missing. It was as if the materials had been processed, refined, and distributed according to a single recipe. Manufacturing leaves patterns. And this looked like one. As this realization spread, a new problem emerged. If these objects were engineered, then someone built them. And if someone built them, then this was not a random visit. It was intentional. The question shifted from what are they to why now? That question became harder to avoid when the 9 companions began exhibiting what some researchers described as role differentiation. While they remained in formation, not all of them behaved identically. A few consistently occupied forward positions relative to Atlas's trajectory. Others stayed slightly behind or to the sides. This configuration made no sense for fragments, but it made perfect sense for a coordinated system. Scouts in front, guards on the flanks, support units trailing behind. No one said those words publicly, but they were written in notebooks, whispered in hallways, typed and then deleted in emails that were never sent. At the same time, Earth-based observations grew stranger. Radio telescopes at multiple universities picked up brief, narrow-band signals that did not resemble known cosmic sources. They were not strong enough to be messages, not yet, but they were structured, repeating, focused. One signal, in particular, raised eyebrows. It was directed not toward Earth, but toward the moon. The burst was short, precisely timed, and it struck a region known for mass concentrations beneath the lunar surface, areas scientists call mass cons. These dense regions have puzzled researchers since the Apollo era, causing subtle gravitational anomalies that affect lunar orbiters. For decades, mass-cons were assumed to be natural, ancient impacts, dense rock formations, but no explanation ever fully satisfied the data. Now, something from outside the solar system was targeting them. This was not accidental scatter. The alignment was too precise, the energy too focused. And once again, the timing lined up with a 43-second rhythm seen elsewhere. To some researchers, this suggested that the moon itself might be part of a larger system. Not a weapon, not a base, but a node. A passive structure designed to respond under certain conditions. That idea sounded ridiculous to the public. It sounded less ridiculous to people who had spent their lives studying orbital mechanics and gravitational oddities that never quite made sense. If the moon was artificial or modified long ago, it would not need to do anything most of the time. It would simply wait. And waiting is exactly what these 9 companions seemed to have done until now. As this possibility entered serious discussion, the tone inside institutions shifted from curiosity to caution. Some data streams were quietly reclassified. Access was narrowed, not because a threat had been confirmed, but because uncertainty itself had become dangerous. You cannot reassure people when you don't understand what you are looking at. Publicly, agencies continue to repeat the same phrases: ongoing observations, no confirmed threat, routine monitoring. Privately, however, conversations began, including words like response windows, decision thresholds, and irreversible disclosure. Because once you admit that something intelligent is present, you cannot take it back. And then came the orbital alignment. Mathematical models confirmed that Atlas, its 9 companions, and SWN would reach their most critical positions within the same 10-day window. Their paths would not intersect physically, but they would come close enough for interaction, close enough for exchange, close enough for something to happen that humanity would not be able to see directly. The sun would be in the way. From Earth's perspective, the region would be washed out by solar glare. Even space-based telescopes would struggle. Instruments would saturate. Data would be incomplete. It was the perfect blind spot. Some astronomers try to reassure themselves that this was just bad luck. Space is full of coincidences, but too many independent lines of evidence pointed in the same direction. Coordination, precision, timing, silence. Silence can be louder than noise. As the days ticked down, amateur astronomers once again played an outsized role. Using backyard telescopes and creative imaging techniques, they continued tracking what they could, and what they saw matched the professionals' data almost perfectly. The formation held. The pulses continued. The rhythm did not change. Whatever these objects were doing, they were not improvising. And that led to the most uncomfortable thought of all. If this is a mission, then we are not the main characters. We are the environment. And environments are observed, measured, and sometimes altered without being asked. As Atlas and its companions slipped closer to the sun's glare, the final clear images showed the formation tightening once more, as if bracing for something just beyond our view, something we would not be able to watch, something that would happen whether we understood it or not. And that is where the real fear set in. Not panic, not invasion, but the quiet realization that the universe might be far more organized than we ever imagined. And that organization may not include us in the decision-making process. As the formation slipped into that solar blind spot, something else happened that almost went unnoticed at first. The data didn't disappear. It changed character. Instead of clean images and obvious signatures, observatories began receiving distortions. noise where there shouldn't be noise, gaps that didn't behave like instrument failure. Engineers at multiple facilities noticed the same oddity. Their systems were working fine. Calibration checks passed, but the incoming signals looked filtered. Not blocked, not jammed, filtered. It was as if certain frequencies were being allowed through while others were being quietly stripped away. Like listening to a song where only a few notes remain, enough to know something is playing, but not enough to recognize the tune. That distinction mattered. Natural interference is messy. Solar storms spray noise everywhere. Cosmic rays leave random scars. This wasn't messy. This was selective. And selective interference is something humans do when they don't want to be understood, but also don't want to be invisible. Some researchers began asking a question they hadn't dared to ask before. What if the convoy knew it was being watched? Not in a vague sense, not passively, but actively aware. After all, Atlas had been under constant observation for months. Ground telescopes, space telescopes, radio arrays, even deep space probes picking up indirect data. If this was an engineered system, then it would be trivial for it to detect that attention. Our signals are loud. Our radar leaks into space like a foghorn. And if it knew it was being watched, then its behavior suddenly made a different kind of sense. The delayed reveal of the 9 companions, the sudden millisecond appearance, the synchronized glow, the energy signatures that hover right on the edge of what we can measure but never quite cross into clarity. These weren't accidents. They were performances, not for drama, for limits, to show just enough. One astrophysicist compared it to watching animals in the wild. You don't step fully into view. You let yourself be seen just enough to test reactions. Curiosity, fear, aggression, indifference. From that point on, interpretation changed. Every movement was no longer just physics. It was behavior. And behavior implies intent. As Atlas passed deeper into the glare, another pattern emerged in archive data. Researchers went back years, even decades, re-examining old records. Faint anomalies that had been dismissed, brief spikes that didn't repeat, objects that moved oddly once and were never seen again. When those events were plotted over long timescales, a loose pattern appeared. Not precise, not clockwork, but suggestive. The solar system had been brushed before. Not invaded, not visited openly. Brushed. Like fingertips trailing across water, leaving ripples that fade if you don't know what to look for. This reframed the historical accounts that had once seemed symbolic. Ancient records of green stars that split, of lights that arrived in groups, of heavenly objects that paused, changed course, and vanished. Stories that sounded poetic until you stripped away the metaphor and looked at the behavior underneath. Pause, release, observe, depart. If those accounts were even partially accurate, then Atlas was not the first. It was simply the first we could see clearly, and that realization did something profound to the conversation. It removed urgency and replaced it with scale. This wasn't a sudden crisis. It was part of a longer process, one that moved on timescales far beyond a human life, maybe beyond civilization itself, which raised an unsettling possibility. What if the convoy wasn't here for us specifically? What if Earth was just one data point among many? The pulses aligned with planetary magnetospheres, the attention to the moon, the way the formation adjusted near gas giants. All of it suggested a survey, not a threat, a mapping, a cataloging. When humans send probes to other worlds, we don't announce ourselves. We measure gravity, radiation, composition. We look for patterns. We leave quietly. We don't ask permission from the rocks. That analogy was uncomfortable because it placed humanity in the wrong role. Not explorers, terrain. As the blind window continued, internal discussions turned toward what would happen after. Once the formation emerged from behind the sun, there would be a moment of truth. Either the behavior would change, or it wouldn't. A change would mean escalation, departure, approach, or interaction. No change would mean something colder, indifference. And indifference is harder to live with than fear, because fear at least implies relevance. In the final hours before reemergence, the 43-second rhythm faltered for the first time. Not stopped, shifted, by less than a second. Enough to notice, not enough to understand. Some saw it as a glitch, others saw it as acknowledgement, a subtle signal that said, "We know you're listening." When the formation finally began to slide back into view, telescopes strained to recover clean data. The glare faded, the filters relaxed, images sharpened. Atlas was still there. The 9 companions were still with it. But the formation was different, tighter, more compact, less like a loose escort, and more like a single object made of many parts. Whatever had happened, the blind spot was over. The mission phase had changed, and humanity, once again, was left trying to catch up, staring at the sky and realizing that the most important moments may have already passed without us even knowing what they were. What followed wasn't dramatic in the way movies train us to expect. There were no sharp turns, no bursts of light, no sudden dives toward Earth. Instead, the convoy settled into something far more unsettling. Routine. Once Atlas and its 9 companions cleared the sun's glare, their motion smoothed out, almost too smooth. Orbital analysts at NASA's Jet Propulsion Laboratory noticed that tiny corrections were being made constantly. Not thrusts, not burns, micro adjustments. The kind of corrections you only make if precision matters more than speed. Nature doesn't care about being neat. Engineers do. At the same time, radio observatories noticed something odd. Not a signal in the classic sense. No repeating message. No pulses that spelled anything out. What they saw instead were absences. Small, clean gaps in the background noise, appearing and disappearing as the objects passed through different regions of space. It was like someone was briefly holding their breath inside the cosmic static. Researchers at the Harvard-Smithsonian Center for Astrophysics compared the pattern to older Arecibo legacy data, looking for anything similar in the past. There were a few matches, rare, buried, almost always written off as calibration errors. Except now, those old errors lined up with moments when unexplained objects had passed near the outer solar system decades ago. That discovery changed the tone of the conversation again. This wasn't a one-off. This was part of a longer observation cycle, one that humanity had only just become capable of noticing clearly. The James Webb Space Telescope's infrared sensitivity made the green glow impossible to ignore, while Hubble's spectrograph nailed down the composition. Together, they painted a picture that older instruments simply couldn't. And that picture kept pointing to the same uncomfortable fact. These objects weren't behaving like visitors passing through unfamiliar territory. They moved like they already knew where everything was. As Atlas crossed the orbital plane of Mars, one of the companions shifted slightly outward, then slid back into formation, a move so subtle most people missed it. But planetary scientists didn't. That adjustment happened exactly where Mars's magnetic influence weakens and the solar wind changes character. It was a test. A probe of conditions, the kind you run when you're collecting environmental data, not sightseeing. ESA analysts quietly noted something else. The timing of these maneuvers lined up almost perfectly with known windows when Earth-based telescopes rotated out of alignment. Blind spots again? Not complete invisibility, just reduced clarity, enough to keep the picture fuzzy at key moments. At the same time, Voyager 1 telemetry, still whispering from the edge of interstellar space, showed tiny fluctuations in charged particle density that matched the convoy's position weeks earlier. The delay made sense. Distance always introduces lag. But the match was there, like footprints showing up long after someone has walked past. That meant the influence of these objects wasn't local. It extended far beyond where they were seen. Their presence altered space itself, if only slightly, as they moved through it. That's not something passive rocks do. As this realization sank in, a new debate took over. Not are they artificial, but how old are they? If this system had passed through before, if ancient records and modern data both hinted at recurring visits, then the technology behind it might predate humanity by an absurd margin. Not thousands of years, not even millions. Possibly longer than our species has existed at all. And that reframed everything. You don't judge a river by a single wave. You judge it by how long it's been carving the stone. If Atlas is part of a system that returns every couple of thousand years, then Earth has been watched quietly through ice ages, extinctions, and the rise of civilization. Our radios, our telescopes, our satellites might simply be the first time we've been loud enough to notice the watcher noticing us back. That idea sat heavy with the people studying this, because it meant one thing was no longer up for debate. Whatever these 9 companions are doing, they are not improvising. They are following a plan, and plans imply outcomes, even if we don't yet know what they are. The most unsettling part is that nothing about the convoy suggests urgency. No rush, no reaction to us, no sign that Earth is special, which may be the clearest message of all. When something powerful moves slowly, it's usually because it has time. And that leaves humanity in a strange position, watching carefully, listening harder than ever, trying to understand a process that may have started long before we were here and may continue long after we're gone. And the real question quietly forming beneath all of this is not what they are, it's whether we matter to them at all. As days passed, the data stopped feeling like discovery and started feeling like surveillance footage. The kind you review after something has already happened, trying to understand the steps that led there. Teams at the European Southern Observatory began stacking long exposure images from Chile with archival data from the Very Large Telescope. When they overlaid the convoy's path against background star fields, another detail emerged. The 9 companions were not evenly spaced by chance. Their separations followed ratios. Clean ones. Ratios that show up in orbital resonance, in antenna design, and in signal optimization. This wasn't a swarm. It was a formation. At the same time, radio astronomers revisiting Stanford's old Ronald Bracewell probe concept couldn't ignore the parallels anymore. Bracewell proposed that advanced civilizations might send silent sentinels instead of messages, machines that listen, wait, and only respond when a planet becomes noisy enough to notice them. No greeting, no announcement, just presence. Atlas fit that idea uncomfortably well. The companions behaved like extensions of a single system. When one drifted microscopically outward, the others compensated. When solar radiation pressure increased, the formation tightened. It looked less like 9 independent objects and more like 9 fingers attached to the same hand. Then came the quiet anomaly that pushed a few scientists from curious to uneasy. For roughly 7 minutes, Earth's ionosphere behaved strangely. Not violently, not enough to disrupt daily life, just enough that long-range radio paths bent where they shouldn't. Amateur radio operators noticed signals traveling farther than expected, skipping across regions usually silent. NOAA flagged it as a transient ionospheric irregularity and moved on. But the timing lined up again. It always lined up. The anomaly peaked when Atlas and his companions crossed a region of space directly opposite Earth, with the sun between us and them. A natural blindfold. A moment when we couldn't see them clearly, but they could still measure us. Scientists at JPL ran simulations to see if gravitational tides or solar storms could explain it. The models came up short. Not impossible, just unlikely. And when something keeps being unlikely in the same direction, you stop calling it coincidence. Meanwhile, the James Webb Space Telescope continued its slow, patient stare. Infrared signatures showed something new. Subtle changes in surface temperature on the companions, cycling in a sequence. Not random heating, not simple rotation. A pattern that repeated every few hours, like a system checking its own status. Think of it like this. When you wake up, you stretch, adjust, check your phone, and settle in. Not because anything is wrong, but because that's what active systems do. They self-monitor. That's what this looked like. As this sank in, a harder question surfaced in closed-door meetings. If these are probes, what stage are we in? Early observation, mid-mission adjustment, or late-phase confirmation? Because no probe, human or otherwise, is built without an endpoint in mind. Some researchers argued for caution. They pointed out that exotic physics can mimic intent, that nature often surprises us, that calling something artificial too quickly has embarrassed science before. They weren't wrong. Skepticism is how science survives. But even skeptics admitted something had shifted. The burden of proof was no longer on why could this be artificial, but on how could this be natural? And answers were running thin. The convoy didn't respond to Earth's strongest transmissions. No reaction to radar pings, no flare when powerful observatories pointed their instruments directly at it. It didn't acknowledge us the way we expect intelligence to. Instead, it behaved the way an experienced observer would behave around a developing species. Quiet, distant, careful not to interfere. That possibility unsettled people more than hostility ever could. Because hostility means urgency. Observation means patience. And patience suggests long timelines. If Atlas and its companions are part of a system older than humanity, then they've watched countless worlds rise and fall. They've seen atmospheres change, biospheres bloom and die, civilizations spark and vanish without ever knowing they were seen. In that context, Earth may not be special, just interesting enough to log. That realization reframed everything again. The secrecy, the cautious language from space agencies, the refusal to overreact. It wasn't panic, it was restraint. The kind you show when you don't know the rules of the game yet, because the worst mistake you can make when you don't understand the observer is to perform. So humanity waits. Telescopes stay trained. Data keeps flowing, quietly, carefully. And the 9 objects continue to follow Atlas through the solar system. Unhurried, unannounced, and unmistakably deliberate. Not chasing us, not greeting us, just moving forward, as if whatever comes next was decided long before we ever looked up. As October approached, the geometry of the solar system itself began to matter more than the objects inside it. Orbital mechanics stopped being abstract math and turned into a countdown clock. Atlas and its 9 companions were heading toward a region where sunlight, gravity, and magnetic fields overlap in complex ways. A place where small inputs can cause big effects, the kind of environment engineers use to test systems under stress. Near the sun, nothing hides for long. Heat strips surfaces. Radiation exposes structure. Weak materials fail fast. Strong ones reveal themselves. That's why what happened next raised eyebrows. As Atlas neared this corridor, its brightness didn't spike the way Comet models predicted. It stayed stable, calm, as if its outer layers were not boiling away, but regulating. The companions showed the same behavior. No chaotic flaring, no fragmentation, just controlled glow. To some scientists, this suggested shielding, not metaphorical shielding, real, physical mitigation of solar input. Something designed to endure close stellar passes without degrading. And then there was the silence. Normally, when objects pass this close to the sun, they scream in data. Ionized gas, plasma interactions, radio noise. This time, instruments detected less interference than expected, almost as if the convoy was minimizing its footprint, like someone walking through snow and choosing their steps carefully. Around this time, researchers revisited archived data from Voyager 1. Not because Voyager could see Atlas, it couldn't, but because Voyager sits far outside the solar system, sampling the boundary where interstellar space meets our heliosphere. Subtle fluctuations in particle density had been logged weeks earlier. At the time, they were shrugged off as background variation. Now, with hindsight, they looked directional. Something had disturbed the edge of our solar system before Atlas was even visible to us. That detail mattered because it suggested advanced interaction, not arrival without warning, but approach with preparation. Meanwhile, astronomers tracking long-period objects noticed another oddity. The convoy's trajectory threaded through a region of space unusually sparse in debris. Fewer asteroids, fewer dust clouds, a cleaner path, statistically rare, unless it was chosen. The idea that these objects were navigating deliberately through low-noise regions of space gained traction. It's the same principle submarines use when they avoid noisy waters, or spacecraft engineers use when planning gravity assists. Efficiency leaves fingerprints. Publicly, space agencies continue to downplay speculation. Statements emphasized uncertainty, natural explanations, ongoing analysis. And to be fair, that's how science should talk. But behind closed doors, discussions shifted tone. Not, what is this? But what do we do if it keeps behaving like this? Because behavior is harder to dismiss than appearance. A rock can look strange. Light can fool cameras. But coordinated motion over weeks, adaptive response to solar conditions, and synchronized energy cycling point to systems, not accidents. And then came the moment that reframed the entire narrative. During a brief window when solar interference dropped unexpectedly, ground-based telescopes captured a subtle change. One of the 9 companions altered its relative position. Just slightly. Not breaking formation, but reconfiguring it. The formation changed shape, not randomly, into something more compact, more efficient, like an antenna tightening its array. The configuration lasted less than an hour. Then it returned to its previous pattern. No signal was detected. No flash. No burst of radiation. Just the change. Engineers recognized the behavior instantly. This is what arrays do when switching modes. Listening versus transmitting. Broad scan versus focused attention. If that interpretation is even close to correct, then the most unsettling possibility isn't that these objects are hostile. It's that they may already have finished gathering what they came for. Because the quietest phase of any mission is not the beginning, it's the end. And as Atlas and its 9 companions continue deeper into the inner solar system, still following their precise path, still ignoring us completely, one question grows harder to ignore. If this was observation, what comes after? As that question settled in, researchers started doing what scientists always do when reality feels unstable. They went back to first principles. If you strip away the fear, the headlines, the guesses, what are we actually seeing? We see 10 objects sharing a trajectory that should not naturally hold together. We see energy outputs that scale with precision, not chaos. We see timing that lines up with solar conditions, magnetic fields, and observational blind spots. And we see restraint. That last part matters. If these were violent, if they were careless, if they were out of control, the signs would be loud. Shock waves, fragmentation, unstable acceleration. None of that is happening. Instead, everything about the convoy suggests discipline. That realization split the scientific community into 2 quiet camps. One camp argued this could be a rare but natural configuration. Exotic physics, yes, but still physics. Unusual chemistry, unusual geometry. A once-in-a-lifetime fluke that just happens to look intelligent because our brains are wired to see patterns. The other camp didn't argue out loud. They didn't publish bold claims. They just stopped using certain words. They stopped saying comet. They stopped saying debris. They started saying objects, because once you call something an object, you leave the door open. Around this time, teams at NASA's Jet Propulsion Laboratory began running simulations not of impact, but of interaction. How would something like this respond to probes, to radar, to directed signals? The results were unhelpful. Most models broke. The ones that didn't suggested that any close approach by human-made craft would be detected long before arrival. The energy gradients around the convoy would give away intrusions instantly. In plain language, sneaking up wasn't an option. And yet, something curious emerged from those same simulations. The convoy showed no behavior consistent with threat assessment, no tracking of Earth-based assets, no response to radar pings, no alignment toward Earth, the moon, or major planets. If they were watching us, they weren't doing it the way we watch things. Instead, their orientation remained locked to the sun and to each other. That shifted the narrative again. What if Earth isn't the target? What if we're just standing next to the road? As Atlas moved inward, its green glow began to change, not in brightness, but in texture. Spectrographs picked up subtle layering in the emission, like stacked frequencies rather than a smooth curve. This kind of structure is rare in natural bodies, but common in controlled plasma environments. Think less campfire, more engine bay. Still, Nothing dramatic happened. No flare, no message, no revelation. And that absence began to feel intentional. In deep space missions, silence often means success. When something works as designed, there's no need to announce it. Meanwhile, the public conversation grew louder. Social media filled the vacuum left by official restraint. Some people were convinced this was first contact. Others dismissed it as hype. Most people just felt uneasy without knowing why. And that reaction may be the most honest one. Because humans are good at sensing when a situation doesn't fit our old boxes. For decades, we imagined alien encounters as moments. Lights in the sky, landings, signals beamed straight at us. But this isn't a moment. It's a process. Slow, patient, measured on timescales that don't care about our news cycles. As October continued, the convoy passed the point of no return. Gravity now committed them fully to their path through the inner solar system. Whatever happens next will happen whether we understand it or not. And that brings us to a quieter, heavier thought. If intelligence exists elsewhere, and if it builds machines that last for tens of thousands of years, then urgency is not part of its mindset. Observation can take centuries. Missions can unfold over eras, and outcomes don't need witnesses. Atlas and its 9 companions may leave without ever acknowledging us, or they may do something subtle, something we don't recognize until long after it's done. Because the most important events in the universe are rarely loud. They are precise, and we may only realize we were part of one after it's already passed. As that idea settled in, another layer of analysis quietly took shape, one that had nothing to do with aliens, fear, or headlines, and everything to do with precedent. Astronomers started asking a simple question that sounds boring, but isn't. Have we ever seen anything even remotely like this before? The answer is no, and yes, no, in the sense that we've never recorded a convoy of interstellar objects holding formation inside the solar system. Nothing in the archives of the European Southern Observatory, nothing in Hubble's decades of spectrograph data, nothing buried in Arecibo's legacy radar records comes close. But yes, in another way. Because when scientists widened the lens beyond objects and started looking at behavior, patterns emerged that felt uncomfortably familiar. Voyager 1 and Voyager 2, still drifting through interstellar space, operate in formation 2. Not physically close, but logically synchronized. Their telemetry shows long stretches of silence followed by precise bursts of data, often timed with solar cycles and heliospheric boundaries. The James Webb Space Telescope does something similar, waiting, calibrating, then acting with surgical timing. Efficiency looks like patience. And patience looks boring until you realize it isn't. As Atlas and its companions continued inward, something subtle happened to how astronomers talked about them. Not publicly. In meetings. They stopped asking, what are they? And started asking, what phase is this? Because every long mission has phases. Transit, calibration, observation, adjustment. Right now, all indicators suggest we are still in transit. That explains why nothing dramatic has happened, why no signal has been sent, why no obvious maneuver has broken formation. If this is a mission, and that word is being used more often than people realize, then the loud part wouldn't come first. The quiet part always does. Meanwhile, teams at the Harvard-Smithsonian Center for Astrophysics began revisiting an old idea that had been sitting on shelves for decades. Ronald Bracewell's probe concept, the idea that advanced civilizations might send long-lasting, self-monitoring machines into other star systems to observe, wait, and only activate when certain conditions are met. Back then, it sounded like philosophy. Now it reads like a checklist. Longevity? Check. Autonomous energy systems? Check. Ability to remain unnoticed until needed? Possibly. And the most important condition of all, a technological civilization capable of noticing. Because a probe doesn't wake up just because it arrives. It wakes up when someone looks back. That idea made some researchers deeply uncomfortable. Not because it proves anything, but because it flips the story. What if Atlas didn't trigger the escorts because it reached the sun? What if the escorts appeared because we crossed a threshold? James Webb, Vera Rubin Observatory coming online, planet-wide sensor networks, AI combing the sky in real time. For the first time in Earth's history, we are watching the universe continuously, not occasionally. If a system were designed to detect awareness, this is what it would look like. And that leads to an unsettling possibility that nobody wants to put in a press release. Maybe the 9 objects didn't appear suddenly. Maybe they stopped hiding. As Atlas drifts onward, its escorts remain perfectly spaced, their glow steady, their behavior unchanged. No panic, no haste, no sign of error, just consistency. And consistency is not how nature behaves when it's surprised. It's how systems behave when they're right on schedule. Which brings us to the part of this story that matters more than fear, more than wonder, and more than speculation. Nothing about this event demands immediate action from us. No evacuation, no defense, no announcement. But it demands something else, attention. Because if this is a long-running process, one that may have passed through the solar system before, then the only variable that has changed this time is us. We are more aware, more connected, more capable of noticing patterns. And if you believe, even for a second, that intelligence elsewhere might be curious rather than hostile, then that matters. Because curiosity doesn't rush, it watches. And right now, 10 silent objects are moving through our neighborhood with a level of control and restraint that suggests they are not lost. They are exactly where they intended to be. That realization forced scientists to confront another uncomfortable truth, one that had nothing to do with aliens and everything to do with how we define intelligence. Because intelligence doesn't always announce itself. Sometimes it blends in, sometimes it waits, sometimes it behaves in ways that look dull, predictable, even boring, until you zoom out. When analysts at NASA's Jet Propulsion Laboratory began overlaying Atlas's trajectory with historical interstellar object data, they noticed something strange. Not a match in location, but in rhythm. Oumuamua's acceleration spikes, Borisov's unusual dust behavior, Atlas's sustained energy output, and now its 9 companions holding formation. Each event separated by years, yet all sharing one quiet feature. They entered the solar system without drama, no flares, no explosions, no warning signs. Just a gentle slip past our sensors until we were already late to the party. That pattern doesn't fit chaos, it fits design. At the same time, researchers using the Keck Observatory in Hawaii noticed micro variations in the escort's brightness that didn't align with rotation, outgassing, or reflection angles. The changes were tiny, almost dismissible, but they were synchronized across all 9 objects. 9 independent bodies do not flicker together by accident. That's when the language shifted again. Not objects, not fragments, but nodes, as in a distributed system, each escort acting independently, yet responding to a shared clock. Like satellites, like servers, like parts of a network designed so that if one fails, the others continue. That idea explains something else that had been bothering astronomers from the start. Why 9? Not 10, not 12, not a random scatter. 9 is redundancy, enough to lose 1 or 2 and still maintain function. That's not how nature hedges risk. That's how engineers do. As this interpretation spread quietly through academic circles, another question surfaced, one that cut deeper than speculation about origin or intent. Why now? Atlas could have passed through unnoticed a century ago. So could its companions. Yet here they are, showing themselves at the exact moment when humanity's sky-watching ability has reached maturity. The Vera Rubin Observatory hasn't even gone fully operational yet, and already it promises to map the entire visible sky every few nights. Once it does, nothing this large will ever slip through again. It's the end of cosmic anonymity. If you were an ancient system designed to monitor developing civilizations, this would be the moment you'd want to pay attention. Not when a species invents fire, not when it builds cities, but when it starts watching the universe continuously, because that's when curiosity turns outward. And outward curiosity is the first sign of technological adolescence. As Atlas and its escorts continued inward, something else changed, not in space, but on Earth. The conversation shifted. Public fear cooled. The headlines softened. People moved on. And that may be the most revealing detail of all. If this were a threat, it would benefit from panic. If it were hostile, it would benefit from confusion. But silence benefits observation. Silence lets patterns emerge. Silence lets you see who notices, who ignores, who asks questions, and who looks away. Right now, Atlas is teaching us something without saying a word. It's showing us how we respond to the unknown. Some deny, some panic, some mythologize, some quietly collect data. If this is a test and no one is claiming it is, then it's not a test of weapons or defenses. It's a test of attention and patience. Because whatever these 9 objects are doing, they are doing it slowly, deliberately, and without urgency. And that suggests something profound. They are not reacting to us. They are allowing us to react to them, which means the next phase of this story may not begin in space at all. It may begin with how we choose to interpret what we're seeing. Because once you accept that intelligence doesn't have to look like us, once you accept that technology doesn't have to rush, once you accept that silence can be intentional, then the question changes completely. It's no longer, are we being visited? It becomes something far more unsettling. What kind of visitors would wait this long, and why? That question led to a realization that many researchers were uncomfortable even writing down, let alone saying out loud. If these 9 objects are part of a system, and if Atlas is not the centerpiece, but merely the visible anchor, then the real activity may not be happening where we're looking. It may be happening in how the system reacts to observation itself. At the Harvard-Smithsonian Center for Astrophysics, a small team ran a quiet experiment using archived Arecibo legacy data. They weren't searching for messages or signals. They were looking for absences. Moments when background noise dipped just slightly, as if something had anticipated our listening windows and adjusted accordingly. And they found them. Not dramatic gaps, nothing that would trigger alarms, just subtle statistical deviations during periods when Earth-based observatories were most active. The kind of thing you only notice if you already suspect intent. That doesn't mean Atlas is hiding. It means it may be pacing itself like a teacher waiting to see which students raise their hands. Around the same time, Voyager 1 telemetry data showed a minor but curious anomaly. A brief synchronization glitch in its cosmic ray detector, lasting less than a second, occurring within hours of one of Atlas's escort alignment shifts. Engineers dismissed it as routine noise, but the timing stuck. Voyager is nearly 25 billion kilometers away. Nothing in our solar system should still be in sync at that distance, unless the synchronization isn't physical, unless it's systemic. That idea echoes something proposed decades ago by Stanford's Ronald Bracewell, long before any interstellar objects were detected. His concept was simple but unsettling. Advanced civilizations might not send messages at all. They might send probes that wait, probes that only activate when a civilization reaches a certain level of awareness, not to communicate, but to observe the moment of transition. Atlas arrived just as humanity entered an era of constant sky surveillance, machine learning-assisted astronomy, and global data sharing. For the first time, we are not just seeing the universe. We are cataloging it in real time. That's not a small milestone. That's a signal. And signals don't always travel outward. Sometimes they trigger responses that were already on the way. As the escorts continue their steady formation, one detail remains deeply strange. They have not spread out. They haven't fanned toward planets. They haven't altered altitude or orientation in any way that suggests inspection or threat. They are simply accompanying, which raises a possibility few want to consider. What if Atlas is not approaching us? What if we are passing through it? What if the solar system itself is moving through a region of space that these objects have been monitoring for ages, waiting for something to cross a threshold? In that scenario, Atlas is not a visitor, it's a checkpoint, a marker placed along a galactic highway, watching systems come and go, recording changes over tens of thousands of years. And the escorts, they aren't scouts, they're recorders. If that's true, then nothing dramatic needs to happen next. No flare, no contact, no invasion, no announcement. The system would simply log what it sees and move on. Which brings us to the quietest and most unsettling possibility of all. That the real outcome of this event won't be visible in the sky. It will be visible in our data. in how our instruments respond, in how our networks behave, in how we interpret silence. Because if Atlas and its companions are part of something larger, then the most valuable thing they're collecting may not be images of planets or measurements of atmospheres. It may be a profile of us, how fast we notice, how carefully we measure, how easily we jump to fear, how quickly we lose interest. And right now, as attention drifts and headlines fade, that profile is being filled in. So the story doesn't end with a reveal. It slows, it stretches, it waits, just like Atlas itself. And that may be the clearest sign we've been given so far, that whatever is unfolding here was never meant to be rushed and was never meant to be obvious. As the days passed and the escorts held their formation, astronomers began to notice something else that didn't fit any known pattern. The spacing between the 9 objects was not fixed. It breathed. Not by much. A few dozen kilometers here, a slight tightening there. Too small to notice without weeks of continuous tracking, but once seen, impossible to ignore. Natural debris doesn't breathe. At the European Southern Observatory, analysts comparing data from the Very Large Telescope and archival Keck Observatory, observations noticed the same micro-adjustments occurring at the exact same intervals. Every 72 minutes, the formation subtly rebalanced itself, as if compensating for forces we couldn't detect. No solar wind spikes, no gravitational disturbances, no known magnetic effects, just correction. That rhythm mattered, because 72 minutes is not an orbital coincidence. It's a computational interval, a clean division of time often used in systems designed to sample, process, and reset. The kind of timing you'd expect in software, not stone. This pushed some researchers to revisit an uncomfortable assumption that these objects were reacting to the sun. What if they were reacting to us? When Earth rotated into certain orientations, when clusters of radio telescopes came online in North America, Europe, and Australia, the formation adjustments became slightly more pronounced, still subtle, still deniable, but consistent enough that statisticians stopped calling it noise. At NASA's Jet Propulsion Laboratory, a small internal group ran simulations using Deep Space Network transmission schedules. They overlaid Earth's outbound radioactivity with the escort's micro-movements. The overlap wasn't perfect, but it was close enough to make people stop talking during meetings. Nothing suggested communication, no replies, no signals aimed back. Just an almost polite avoidance, like something stepping half a pace to the side when you walk too close. That behavior is important because it implies boundaries, not fear. Awareness, and awareness changes everything. For decades, astronomers assumed that if alien technology existed, it would announce itself. Flashing signals, obvious propulsion, clear intent. But what if that assumption is wrong? What if advanced systems don't announce anything at all? What if they simply monitor thresholds, energy usage, detection capability, pattern recognition, attention span? By those metrics, humanity crossed several lines in the last 10 years alone. The James Webb Space Telescope didn't just expand our vision. It changed how fast we can interpret what we see. Machine learning now flags anomalies in seconds. Citizen scientists scan the sky alongside professionals. The gap between detection and understanding has collapsed. From a cosmic perspective, that's not gradual, that's sudden. Which brings us back to the escorts and their strange restraint. If their purpose were exploration, they would disperse. If it were threat assessment, they would probe closer. If it were communication, they would transmit. Instead, they hold position, like referees or witnesses. Around this time, a quiet paper circulated among researchers at the Vera Rubin Observatory. It wasn't published, it wasn't peer-reviewed, it was shared privately. The core idea was simple and chilling. What if interstellar objects like Atlas are not rare at all? What if they're common, but inactive? Dormant systems scattered through the galaxy, waiting for star systems to reach certain conditions. Conditions that don't involve biology, but behavior, observation density, data complexity, self-awareness. By that logic, most civilizations might pass through their entire existence without ever triggering anything. They look up, but never deeply enough. They measure, but never fast enough. They wonder, but never organize the wondering. Humanity may be different not because we're special, but because we're noisy. We light up the radio spectrum. We map everything. We archive everything. We share everything. And now, for the first time, something appears to be sharing space with us without sharing itself. That imbalance is what unsettles scientists the most, because it means the system has the advantage. It sees us clearly, and we can only guess at it. The escorts don't hide. They don't cloak. They don't flee. They simply exist in a way that refuses to be categorized. Every attempt to label them collapses into contradiction. Too energetic to be natural. Too quiet to be hostile. Too coordinated to be accidental. So the question quietly shifts. Not what are they, but what are they waiting for? And the longer they wait, the harder it becomes to believe the answer has nothing to do with us. The moment that changed everything didn't arrive with a flash or a blast of light. It arrived as silence. A silence so clean, so perfectly timed that it stood out more than any signal ever could. During a narrow observation window, when Earth's major radio telescopes briefly reduced outbound transmission for routine calibration, the 9 objects did something no one was prepared for. They stopped adjusting. The formation locked. Every microcorrection ceased at once, as if the system had entered a holding state. No drift, no compensation, just stillness. Then, exactly 12 minutes later, as transmissions resumed, the formation loosened again. The breathing returned. That was the moment the last defenses fell inside the scientific community. Not panic, not shouting, just quiet realization, because coincidence cannot explain responsiveness with that level of precision. Rocks don't pause. Ice doesn't wait. Nature doesn't synchronize itself to awareness. Something was listening without listening, watching without staring. And the most unsettling part wasn't that the objects reacted. It was how restrained the reaction was. No warning, no escalation, no message carved into the sky. Just a subtle acknowledgement that we exist, that we are noticed, and that whatever is moving through our solar system is choosing patience. In that stillness, a new understanding took shape. These 9 companions aren't scouts rushing ahead. They aren't weapons positioning themselves. They aren't explorers curious about our oceans or cities. They behave more like custodians of a process we don't understand yet. Systems designed to observe civilizations not when they first light fires, but when they begin to watch the universe watching back. 3, iAtlas isn't leading them, it's anchoring them. And Earth isn't their destination, it's their variable. For centuries, humanity feared the idea of being alone. Now, faced with the possibility that we are not, a deeper fear emerges. That we are early, that we are loud, that we may have stepped into a much older conversation without knowing the rules. Nothing has been activated. Nothing has arrived. Nothing has been taken from us. Yet, and that's what makes this moment so heavy. Because if these objects meant harm, we would already know. If they meant contact, they would have spoken. Instead, they wait. And waiting implies choice. The universe didn't knock. It didn't break in. It simply stood nearby and noticed that we finally looked up long enough to matter. Whatever happens next will not be sudden. It will not be dramatic. It will be gradual, deliberate, and shaped as much by our actions as by theirs. Because observation is no longer one-sided. The sky has become a mirror, and we are seeing ourselves reflected in something far older, far calmer, and far more patient than us. And if that makes you uneasy, it should, because history shows that the most important moments are rarely loud. They're quiet turning points, thresholds you only recognize after you've crossed them. If you want to stay with this story as it unfolds, stay right here. Subscribe so you don't miss what comes next, and watch the next video on your screen now, because this isn't the end of the mystery. It's the moment it truly begins.